Example 1, determine the quadratic function in vertex form whose graph is given. So let's look at this graph. First let's notice a couple things about it. It opens down. So that's interesting. We'll figure out what that means here in a minute. We also have the y-intercept 0, 1, and we have the vertex 2, 3. So in vertex form, the general form is f of x equals a times x minus h squared plus k. We can actually read h and k. So we have h and k already. H is 2 and k is 3. But let's hold on to those for a second because the only thing we don't know is a, and we can use the fact that we have another x and y. In other words, I'm going to replace f of x with y and write this as a times x minus h squared plus k. And I can use this point where I have an xy that's on the curve and it happens to be the y-intercept, so I have 0 for x and 1 for y. Now I can replace every letter in this equation except for a, so when I have one unknown, I know I can solve for that. So y is 1, it equals a, which I don't know, times x, which is 0, minus h, which I know is 2, squared, plus k, which I know is 3. So now I just have to take 0 minus 2 and then square that. So that's going to be 4a plus 3, and 1 is going to equal all of that. So now I'm just going to solve this algebraically and get 4a equals negative 2. Divide both sides by 4, so a is negative 1/2. Now I have a, I have h, I have k. Now I can go back and write the general vertex form for this graph. So go back to function notation. F of x would be, well, I have a value for a now, negative 1/2. I replace h with the number that is the x-coordinate of the vertex. Make sure you square that binomial. And then I'm going to add k. So this is the equation of this quadratic function in vertex form. Notice a is negative. A is negative 1/2. That's why the graph opens downward.